I'd like to take a moment to talk with you about solution, the cleaning solution capacity in a machine. It affects your productivity in a lot of different ways. A cleaning solution is generally plain tap water that's been added to the solution tank, and you can either add your soap directly into the tank, generally at a ratio of 30 to 1, 15 to 1, 45 to 1 from the concentrate. Now, that all depends on your application. There's so many clean floors today, some people will scrub without any soap at all and be perfectly fine. They're getting the dust up and put that in suspension. So if you're putting solution into your cleaning solution concentrate into your tanks, you must keep in mind that there's a cost associated with that. Two costs. One is the actual cost per gallon of the solution. It can be $5, it can be $10 a gallon. It all depends on how you buy it and what type and concentration of soap are you purchasing. But if you think of this machine has 28, 30 gallons in it, at 30 to 1, you're talking about 1 gallon of solution. So let's say your typical cost here is $8 a gallon. Every time you fill it up, you're spending $8. Now, if you can get by with half a gallon, you're saving money when you consider the entire time frame of the year that you're running the machine. You can only really determine the performance of your solution and at the right ratio by looking at the results on the floor, which is beyond the scope of this video here, but literally measure it, walk behind it, take away some, add some, and see which performance you perceive is the best for your application. But given that, the solution in the machine, in terms of just capacity, the machine is filled and will often run when you're getting a complete coating of water on the floor to the maximum capability of the machine. It can be about 1 gallon a minute for a machine of this type. So if you have a 30-gallon tank, you're going to have 30 minutes of run time before that tank is emptied. So the thing to think about is in your productivity savings, we can talk about that you can go to continuously for an hour and clean, let's say, 30,000 square feet. But in an hour, you're going to have to stop, dump the machine, and fill up the machine because the machine won't run continuously for an hour. We've just said it'll only run for 30 minutes and then you're shut down to replenish your solution. So the result is that how long does it take you to fill up this machine with water? Now, if you're cleaning here and your source for water is way over there and it takes 15 minutes to get there and 15 minutes to get back, and figure out what is your solution input time frame. If water's coming out of the spigot, sometimes it comes out at a gallon a second, and how many minutes is it going to take to fill up your tank? That's something that you can figure out on that end, but it's typically, I allow 15 to 20 minutes for an operator to stop and fill up the tank and go back to use. Now, why is all this important? The thing about it is the bigger the machine, the more solution, the less you have to stop. I can get a machine slightly larger than this, but it's got tanks twice as big. I'm going to have much longer run time before I'm going to have to stop. Another way to control the time you spend stopping, refilling, and the total cost of your solution is instead of applying a gallon a minute, you only apply 1/3 of a gallon a minute. Now, 1/3 of a gallon a minute might be very suitable if you have a very clean floor, your operator's going at a reasonable rate of speed. He might go 90 minutes before he needs to refill the tank. Is the floor clean? That's a decision that you have to make. A gallon a minute may not be necessary. It may be overkill for that application. 1/3 of a gallon a minute may not be adequate. So there is a average typical situation. I like to think in the worst case scenario, these machines will go a half hour, you refill it, and then you move on. And so every half hour, you add another 15 minutes, unless your situation recalls your operator to go so far away that it's going to be more than 15 minutes to refill the tank. So these are considerations when establishing your productivity. This fact must be added into the machine. Now, the more solution they add to the chassis of the machine, the more weight they add. The more weight, the bigger the motors they have to be able to power up that weight. And the bigger the motor, the bigger the batteries, which adds more weight. So the engineers are looking for a compromise that's suitable for all applications. So typically you'll find these machines come in with about 30, 35 gallons maximum in a machine of this size. And the larger frame machines where the weight of the water is less significant to the total weight of the product will go 60. And our very largest machines that we have that are combustion engine machines will go to 100 gallons. But they're wider machines. Another thing that affects how fast you want your solution to flow on the floor is how fast is your operator going. If you're rolling along at about 1.5 miles an hour, the operator's trying to be very thorough. He doesn't need as much solution as if he's going all bent at 3.5 miles an hour down the floor. He needs more solution per minute to be able to adequately cover the requirements going at that level of speed. So you have to factor that in as well. If the man is going to operate the machine at 2.5 miles an hour, again, you're getting into a more average situation. Maybe you're only going to be using 3/4 of a gallon per minute. So these considerations affect your choice of a machine. Does it really matter if you got a 30-gallon versus a 28-gallon? This is actually the 30-gallon machine, and this is the 28-gallon machine. Doesn't really look that way, but you got to look at the specs on the machine. And there'll be some exaggerations by manufacturer when they start talking about recovery tanks, because the recovery tank is a column, and they like to keep the water low. So when they say they have a 40-gallon recovery tank, they're talking about an envelope of air to separate it from the vacuum motor. It really doesn't affect your capacity. If they're giving you 30 gallons of solution, you're going to recover 30 gallons of solution or less. So those features will be identified in the specifications, and you have to apply whether it's meaningful to you or not. At this time, I'd like to continue our discussion about floor scrubbers in general, and specifically these Ryder machines, by discussing some of the elements involved with batteries. Batteries are a key part of this floor scrubber system because they're going to provide all the power to the electric motors, which are going to do all the work. So the size of the battery, the type of the battery, how long the batteries will run, that's something that you should plug into your decision-making process when you're learning about scrubber machines, because it will affect your price and your performance. Now, in the machines that we have here, these are 24-volt systems, which means 4 batteries. A 36-volt system would have 6 batteries, and we'll have 2 12-volt batteries to make up a 24-volt system, and a 20-inch machine that probably just has 2 batteries. This is a fairly common configuration because this type of machine with the 4-battery system, with what the manufacturer generally offers is the smallest battery pack, will typically operate the machine for 2 to 2.5 hours of continuous runtime. Now, when I say continuous, I'm talking about scrubbing runtime. I'm not counting trips around the plant. It is something that you can count on the square footage measurement when you think of continuous runtime. Early in our discussions, we talked about taking the width of the machine and the transport speed of the machine when it's actually in operation, and you can determine square footage. But the square footage in total for the day is going to be dependent upon the total available runtime in the batteries. So if you're getting 30,000 square feet in an hour of scrubbing, then you have a 2-hour battery pack, then you have the potential to clean 60,000 square feet. And after that, the machine will have to be shut down and sent to charge cycle, which can last probably 6 to 8 hours minimum before you can return the machine to operation. When you don't have enough runtime, people are often thinking in terms of, well, maybe if I charge it during lunchtime, I can get another 20 minutes. However, one needs to understand what the characteristic of batteries. When they're in their fully charged state and they're cold, when that energy is leaving the battery for a continuous 2.5 hours, heat is going through the wiring system, heat is going through the motors. All of this heat is building up in the machine, and it has not had a chance to disperse. So if you go back and charge it again, the charger itself is going to generate a certain amount of heat, which is going to reside in the batteries. At some point, you are putting too much heat in the battery. It's coming off a hot situation, and it's being heated again by the charger, and the result is that the liquids inside the battery will start to boil out of the battery and can be lost into the environment. Now, this may be just water vapor, which is not really dangerous to you or your people, but the loss of that water has to be replaced. And what often happens when we have small battery packs that are used excessively, this heat is destructive to the condition of the battery, and it will shorten its life cycle of use. So we want the right size battery for the application. If you go to the largest battery pack that the manufacturer generally will offer, it's going to be significantly more expensive, so you need to be aware of that. You also can be, it's generally understood you're going to get 3 to 3.5 hours of runtime. Now, I've seen people say that they're going to get 4 to 5 hours of runtime. Well, you can determine that from an engineering standpoint, but in reality, I think most people will get this amount of runtime because most people don't scrub under the ideal conditions. When someone says 4 to 5 hours of use, they're probably talking an extremely smooth floor on the lightest level of down pressure with the least resistance to the motors, which is drawing amperage from the batteries. So we're talking about average conditions, average run times. Now, there's two types of batteries in the marketplace. There's lead acid and there's AGM batteries. The glass mat battery here is on the floor. You'll see that it is a sealed battery. There's no access for an operator to open up the battery and see what the condition of the electrolyte is. But if you look over here in the lead acid battery, there's actually caps. And Stephen, if you'll put that camera down where you can see the water level on these brand new batteries, it sits about a 1/4 inch above the lead plates that you can actually see. Now, the advantage is that when this battery eventually does heat up, it's not going to cause the water to expand outside of the shell of the battery, which is really important that it happens, that does not happen, because it can, it's going to be sulfuric acid at this point. When you add water back to the battery, you're blending it in with the sulfuric acid that's in the electrolyte, and we want to contain that electrolyte inside the battery at all times. So lead acid has the ability to lose the water as vapor, and when it comes out of the battery, it's also a very acidic solution, and it can actually corrode certain things in its environment. It's one of the reasons why we like plastic tanks, because plastic is impervious to any of the acidic fumes that might be coming out of the battery. But one of the things that will come out of this battery is hydrogen gas. Hydrogen gas is explosive. Think of the dirigibles. We're dealing with a device that can create an electric spark. If I was to take a wrench and I was working on these batteries and I was to cross both the positive and the negative post and connect those two posts, I'm going to get quite a shock, a spark. And that spark alone can generate and ignite hydrogen, which can create an explosive situation. You can literally blow the tops off of these batteries. And when that happens, you're blowing not only the top of the battery, but you're blowing electrolyte up into the air, which is sulfuric acid, which is very dangerous for people to have that situation occur because it's going to affect them physically. They can lose their sight. They can be burned by the acid in their face. We got a big problem on our hands. So the thing is, we must be very careful when we're handling the batteries. There's another thing that can happen. If batteries are not properly secured or aligned according to the cables in the machine, according to the directions that are printed on the most battery cases, if they're not put in that exact way, you have potential for a shorting or arcing. The shorting occurs when you don't tie the cables that connect the batteries properly. That's pretty obvious. But the arcing is when someone hasn't properly secured the terminals. There's nuts. Stephen, you can come over here and show that, please. These nuts have to be properly fastened and tightened, and if they're not, if there's a gap, if there's a looseness, then the electricity wants to jump from one spot to the other, creating a spark or an arc, and that's the thing that can set off the hydrogen, and that's the thing that can literally blow the top off these batteries and be dangerous to people. That's associated with lead acid batteries. Now the advantage of them is they're half the cost of AGM. They actually, if properly maintained, will last longer than AGM. It's been said that AGM will get more cycles of use, and that possibly AGMs are more durable because they're closely packed cells. They're less subject to vibration, but in general, we're finding in our experience that the lead acid batteries last longer in a machine than AGM. So the issues are, why buy AGM? AGM are sealed. You will not have any hydrogen gas leave that battery. You will not have to have a short cycle where your people are re-hitting the battery with a charge midday and creating a lot of heat. The gases will not leave the battery. As a result, you're not going to end up sulfating your battery because you've lost electrolyte that hasn't been replaced, and all of a sudden you're running your machine on battery that only 50% of the battery can be used because that's the loss of electrolyte inside the battery. So AGM eliminates your maintenance headaches, and if you don't have people to check the electrolyte, then go with AGM. If you have people that are comfortable checking the electrolyte, can check the battery terminals, and maintain the batteries properly, we think you're better off with lead acid batteries. It's up to you and your system as to what is the most practical course of action for your application. But double the cost of the same battery. In general, that's what you're dealing with AGM. Batteries have generally a manufacturer's warranty of 1 year. And batteries can fail. They can be bad right from the manufacturer. So if you're not getting enough runtime on your machine, one of the things you need to check is whether you have electrolyte in the cells. And there's also ways of checking the status of the battery. Each one of these caps indicates a 2-volt cell. And if you put your meter, your hydrometer in there to check the status of the battery, you can determine whether you have a bad cell in an individual battery. And if you check all the cells, you can find out if you're losing runtime due to possibly a manufacturer's defect. If you identify that, then you can get a prorated price on your battery. In other words, if you've had it for 6 months, you'll get 50% of the new battery price. They generally, in warranty, give you up to 90 days complete replacement, and after that it's prorated. Just something to think about. The batteries are the engine of the machine, and you also have to keep in mind conditions affect their performance. So if you have a very cold temperature, like in a cooler environment, you're going to find that if you have temperatures in the 35-40 degree range, you're probably losing 30 to 40% of your potential runtime in the battery as compared to normal conditions of 70 to 80 degrees. So if you have a cooler or cold conditions, you're storing the machine outside in a shed, you have to keep in mind that you might want to get the larger battery pack just to get normal runtime. So these are some of the considerations that you might want to keep in mind when you're making plans for batteries. And certainly make sure your people are trained and aware of how to maintain them, because with batteries we have to talk about safety. And certainly if you have any questions about batteries and safety, I hope you'll give us a call. We'll be happy to assist.